In 1998 BC 18, we're asked which of the following series converge. The first one is the sum from n equals 1 to infinity of n over n plus 2. And you might tell just by looking at that if we were to do the nth term test on that, the nth term test on number 1 would give us limit as n approaches infinity of n over n plus 2, that is equal to 1. That's a limit at infinity. And the degree of the numerator and denominator are the same, the coefficients are the same, so the limit is 1. Now, in order for a series to converge, the basic requirement is that the limit of the nth term as n approaches infinity must be 0. And this is not, so this one diverges by the nth term test. And the nth term test is what we're going to use as our primary first line of defense, you can say, to test whether or not a series will converge. The second one is cosine of n pi over n, and the sum from n equals 1 to infinity. So what you might want to do with some of these is to write out the first few terms of them. Now this one, the limit as n goes to infinity actually does approach 0, so the nth term test is not going to help us here. Cosine oscillates between -1 and +1, so the numerator will stay somewhere between -1 and +1, but the denominator will grow infinitely large, and so that will become 0. But that's only enough to tell us, well, that the nth term test is inconclusive. So we write out a few terms. Starting from n equals 1, we have cosine of pi, which is -1 over 1, and then cosine of 2 pi, which would be 1 over 2, and then we have cosine of 3 pi, which is -1 over 3. And you can see from this that this is becoming the alternating harmonic series. The signs are slightly off. We're starting with a negative instead of a positive, but it converges by the alternating series test. That's one way of looking at it. Alternating series test. Remember what the criteria for that are. It must be strictly alternating, which this is. Strictly alternating. Strictly alternates. And it decreases the limit as n approaches infinity of a sub n is equal to 0. So it strictly alternates and it decreases to 0. So that's an example of the alternating series test, but we know it as the alternating harmonic series which converges. The third is simply the sum from 1 to infinity of 1 over n, which is the harmonic series which we know diverges. You could also look at that as a p series where p is not greater than 1. Recall that to converge a p series must have p greater than 1. And so that does it for this. We have the first one diverging, we have the second one converging, and we have the third one diverging, and therefore we have 2 only, and the answer is B.